Are you struggling to understand how to leverage large language models and chat models to process data efficiently? If you are unfamiliar with how Agentic AI and LangChain can help you integrate these models for seamless input-output operations, then you're missing out on optimizing your AI workflows and staying ahead in this trending field. In today's video, we will show you how to use LangChain to integrate LLMs and chat models for real-world applications like text completion, chat-based interactions, and much more. We will walk you through the differences between LLM and chat models, how to use the APIs for natural language processing tasks, and how to build robust applications using LangChain, a powerful tool in the Agentic AI ecosystem. And if you are ready to take your skills to the next level, our AI Track job program offers hands-on learning with LangChain, Agentic AI, LLMs, chat models, and much more. Also, this program is designed to fast-track your AI/ML career, helping you secure high-paying jobs in the AI/ML field. So check the link in the description to register for the free masterclass. Also, this particular video is a part of our AI/ML Track job-oriented program where professionals like Utkarsh, Rija, Devashish, Roshan, and many others have successfully landed high-paying jobs and top certifications in AI/ML. So join them in mastering these powerful AI tools and accelerate your career. So now let's get started with the video.
So this is already installed. So we are going to explore these models in two ways. Okay. Okay. So I've provided all the keys and everything. Now this is the point where we have reached. So central part of any application will always be your actual language model. That is clear. And this module provides crucial tools for working. So essentially we have two types of APIs. That's what LLMs and chat models. So LLMs or LLM API, we can say, this is a pure text completion models. Okay. So text completion means what? Write down an essay, write a story, create a marketing campaign, something like that. Okay. So the response doesn't necessarily have to be in a very conversational format. Fine. So receives a text string and returns a text string. It is as simple as that. There are many more differences which we will see later. Chat model, on the other hand, they are based on this language model, but with different inputs and output types. So here you can modulate the input and output type. You can instruct the model also to give in a specific output format, and many times that works. Okay. So here it takes a list of chat messages as the input and produces a chat message as the output. Now this is the important part. List of chat messages. Okay. So by default, LangChain maintains a list of all the turns of conversations that you have had with the model. And that list of turns is given to the model for every subsequent turn of interaction that you want to make. Okay, so the clarity and the distinction is coming up more in more detail. But in one line, if I can say, LLM API is to be used with instruct models, and this chat model API is supposed to be used with chat models. Okay, so this is more conversational format, more natural language outputs you will get. Okay, whereas the outputs here coming from the LLM API would be more like transactional. Okay. Um, So all of these LLM providers, they initially provided the instruct models, and soon they found out that instruct models are not very helpful, because if you want to create a chatbot, you need a more naturally sounding statements coming out from the models. Okay, so that is where they fine-tuned these instruct models to follow user instruction, no doubt, but also to give a output in a more natural language, more coherent. Okay, that's where the chat models also came into picture. Okay. Oh, my runtime changed. Fine. So if you change the runtime, you'll have to execute again. No worry, this will be fast. Hmm. Okay, so first we will take the instruct model from ChatGPT. So this GPT 3.5 Turbo. Okay, so the chat model interface, which we will see later, is better, as I've already mentioned many times, because the LLM API does not support some of the chat models. So this is a chat model, and the instruct models will have this suffix. Remember that this is an instruct model. So this will be supported only by the LLM API. So how do I know the LLM API? So please pay attention here. So I'm using the OpenAI directly from the LangChain. Okay, and providing the model name, whatever it is, versus the chat OpenAI. So that is the difference. Either you use the OpenAI or the chat OpenAI. So only the OpenAI part is the LLM interface I was talking about, and the chat OpenAI is the chat model interface. So that is the biggest difference in terms of code. Okay. So fine, I've imported that and explained what is Gen AI in 3 bullet points. So this is the prompt, and now, or maybe what is deep learning? Let's call reinforcement learning in 3 bullet points. Let's see what I get. So RL is a type of machine learning that involves training an agent to make decisions in an environment in order to maximize a reward. So it works on a reward penalty model. Concept of trial and error. Agent learns through interactions with the environment, receives the feedback. Either it is reward or penalty. And the goal is to make the agent learn different situations without explicitly programming that. Perfect. So that's pretty much what we are getting. Now, main differences. This was a instruct model, and this is the turbo model, normal chat model, you can say. And let me just use the same prompt. Okay. Uh, let's say I'll use the same prompt. So I deleted that code. So this is the prompt which I am going to use it here. Okay. And we'll see a lot of other details are present. Okay. So AI message is the actual output coming from the model. You can see very much. These are the actual things. So these are the 3 points. Apart from that, you can see the token usage, response metadata. Can you see? The response metadata has information about the total UKs. So completion token means the total number of tokens in the actual output, the number of tokens in the input. And so total you will be billed for 91 plus 19, that is 110 tokens, because all the input tokens are also billed along with the output tokens. Fine. So total number of tokens which is present in this conversation, okay, in this turn, whatever you call, okay, is 110 tokens. So 19 went as the input. So essentially, this explain what is reinforcement learning in 3 bullet points. That is exactly 19 tokens. And 91 tokens is the output coming from there. Completion details. So accepted everything. There is no issue there. You can just check it out. This is the trace of this API call run. So everything is there. And even usage metadata is also explicitly available if you want. So from the response metadata, I normally use the usage metadata to extract all these tokens. Fine. And let's fetch the main content part. So where is this content part here? I'm just fetching the content part and just printing it. Okay. So these are the 3 points I'm getting. Reinforcement learning is type of machine learning. So see, more or less the outputs are same. It may not be very much evident in terms of difference here because of two reasons. Number one, GPT 3.5 is anyway a slightly older model, so capabilities are limited. And number two, this is a very simple task that we are having. Okay. So the difference between these two is primarily about the interaction style and how model was fine-tuned. Okay, let me do one thing. So right now it doesn't have. Okay, we'll see how we can resolve this for now. So these interaction or chat model types, basically, you can also give the system and user rules. This is very, very easy to do it with a chat model. Okay. Slightly tricky for the instruct models, but all the chat models will definitely support the system rule and the user rule. So essentially this becomes a system prompt and this becomes the user prompt. Okay. So these are completion style, takes a plain text as the input, single shot tasks are good, like summarize this, write down Python code, write down an email, story, essay. So those things. Okay. So chat models are fine-tuned for dialogues, most importantly, and also remembering the context, following conversational cues, and handling clarifications, and finally also responding politely. So these are some few things which the chat models are fine-tuned for. So that is the most important thing. Whereas these instruct models are fine-tuned for instruction following, zero shot. Okay, no prior history. This is the task, and that is how I have to do. So directly doing what the prompt asks, no back and forth conversations needed. It doesn't even store anything in the memory. Fine. So it's like a more instructed GPT family. Now, these instruct models are getting outdated, so you may not see them more in actual use these days. So I got a list of some of these models from the OpenAI webpage, and you can see the earlier Da Vinci models are there. These have all got retired. So these are no longer available. These were all instructed GPT family. Now the only available variant for chat model, sorry, the LLM API is this GPT 3.5. Now all the others like GPT 3.5 Turbo, this is 8K context, this is 16,000 context model, and then all the GPT-4 family models, they are all by default chat models. Okay, so GPT-4, again, this is 16,000 tokens, this is 32,000 tokens. Turbo is again, I think 32,000 or 64,000 tokens. Now, GPT-4o is what we are going to use most often, especially the GPT-4o mini. This is multimodal, so it can take text input, image input, audio input also. Okay. And GPT 4.1, these are now reasoning models essentially also. So that is where the reasoning capability started. Okay. So GPT-5, again, high reasoning, high thinking models are there now. Okay. These are the latest. Okay. So as of now, the cost for GPT-5 mini is much, much less than compared to the others. Because what happens is OpenAI strongly discourages the usage of previous models. And to discourage that, it will increase the cost of the previous models tenfold times at least. Okay. So that people keep on switching to every latest model as it gets launched every 6 months, 1 year down the line. Fine. So quick summary, instruction models are completion style and used via LLM API. And this is the only one active right now. Chat models, these are chat optimized and these are accessible via chat model API. Fine. So OpenAI, as I said, is consolidating these chat models and they will be able to handle both chat and instructions well. So now this is going into the legacy mode. Just left for backward. The only model right now available is this. Okay. It might just get deprecated anytime. Fine. Now coming back to our discussion on system prompt and user prompt. So conversational prompting, I think we have already mentioned. Let me just, yeah. So chat models processes a list of messages, okay? And this list of messages can be your system prompt or user prompt. So what is the main advantage of system prompt? You will set up a high level context, a role mostly about what the LLM is supposed to behave, okay, or act as. That is the system prompt. User prompt is like the specific instruction for a particular task or a activity that you are providing to the model. That is the user prompt ultimately. Okay. So human message is the user prompt, system message is the system prompt, and AI message is the output which comes out from the model. So these are the three keywords that we need to focus on. Okay. So how are they implemented ultimately? So again, I'm using the chat model API. GPT-4 Omni this time I'm using. Um, so you can see the human message and the chat message. Okay. So system message, I'm passing the system prompt here, act as a helpful assistant and give meaningful examples. And this is my human message, which takes in the user prompt. Okay. So this is the user prompt that I am passing. So this messages list, this is your list of messages. And that list of messages, now I am passing it to the model directly. So there is no chaining as of now. The chaining part we will discuss in the next one. Here we are doing direct communication with the models via LangChain. Okay. There are two modes, as I've been repeatedly saying, LLM mode and the chat model mode. So here this is again the chat model mode. So when you invoke, again the execution from the LLM starts and the query fulfillment will take place. So I've got a response. If you want to see the complete response, you can actually print the response and see. So this is the complete response. So here you can see the language. Certainly here are three key points. Now this kind of language you will not get, okay, in an instruct model. This is very much conversational. Okay, instead of directly jumping to these are the three bullet points, it doesn't even say these are the three bullet points. Directly bullet point number one, bullet point number two, bullet point number three. Okay, so and then rest all things are same. Finished reason is sometimes very interesting to watch. Okay, so if you are providing max tokens, then you can see the finished reason as max token reached, something like that also. Otherwise, the usage metadata, as usual, will give you the input is 38 tokens. Why 38? Initially, it was 19 because we did not use the system prompt. Now, even the system prompt that you are passing, sorry, here, that also takes tokens. So, in total, the system prompt plus the user prompt will be 38 tokens right now. Output is 215 tokens, so much more verbose output you get from later models, better models. Okay, so try not to use GPT 3.5 altogether. Just forget it now. By default, use GPT-4o or GPT-4o Mini to save on cost. So these are the two models we are going to take mostly throughout the course. Okay, and GPT-5 if you want, right? So this is the total number of tokens, and let me print the content. Yeah. So now add the past conversation history into messages. This is important. So what I did was my original messages was only this much. Let me just print the original messages. Okay. So currently my messages is the system message and the human message. Now when I am appending the response, what is the response? This is the response. So I'm appending the response to this because it's a list. So it will also get appended. Okay. So let me show you what happens. Okay, so after appending, now you have the system message, human message, and the AI message. Fine. And then what we are saying is, this is the prompt. Again, what did we discuss so far? And then we are further converting that prompt into a human message, that is the user prompt. Yeah, this is what we are doing. We're converting that into a user prompt by using the human message and also further appending it to the messages list. So now your messages list will have four things. The system message initially, then the user message, then AI's response, third thing. And the fourth thing is the new discussion, okay, the new message or prompt by the user. What did we discuss so far? So this way, now you have a complete one turn. Now that one turn is now you are passing directly to the chat GPT. So now it will be able to tell me that, okay, boss, we have discussed the concept of generative AI, highlighting 3 points, this and that. So let me just print the response now. Okay. Now this time the response input. Can you see the input? So output is 126, total is 394, and input is 268. Why is 268? Because originally it was 253 plus this new human message that you have passed. What did we discuss so far? So 253 plus this is now 268 on the right side, if you see. And output is this output so far, whatever we have discussed. And then total token is this. So you are now being charged for 268 input tokens. The only good thing is, the only relief that you get is the input token cost is mostly 1/10 of the output token cost. Okay, so it's not exactly same. Initially, it used to be same as the output token cost. We can just check OpenAI model pricing, and we can just check GPT-4o mini pricing. What is the flagship models? Any one of them? We can just check O4 GPT-4o mini. Can you see? Input tokens is 0.6 per 1 million, and output is this. So if you are implementing caching, that's what I said. If you are implementing caching, it's even lesser.
So today we have explored how to use LangChain to work with LLMs and chat models, understanding the key differences and how they can help you tackle tasks like text completion and conversational AI. This hands-on approach is essential for IT professionals looking to build scalable AI applications. And remember, if you want to dive deeper into LangChain, LLMs, chat models, and other advanced AI topics to fast-track your career, our AI Track Job program is a perfect fit. So learn how to master these skills and secure your place in the AI industry. Check the link in the description and pin comment to register for our free masterclass. Also, stay tuned for more informative videos on AI, ML, Gen AI, and Agentic AI. Subscribe to our channel and hit the bell icon to never miss an update. And if you like the video, definitely make sure that you watch this video next.